now, not just when you get to the job site. And you probably hear people harp about this also, soft job skills. Make sure you're on time, make sure you come to work every day. That's a big thing. And you had a questionnaire 2 weeks ago when we came in. That was one of the things that I put down that people are looking to see. You gotta have those soft skills because people want somebody they can rely on. Now, I'm gonna use these two guys as examples here. Joe's been there 20 years. Joe's been at our shop for 20 years, graduated from Crete-Monee. What year did you graduate?
94.
94.
Yeah.
I'm 25 years older than you then.
Yeah, how about that?
How about that? Nice. And he had a couple jobs that he was working on, but he got some exposure to mechanical operations of different things, and he comes in now, and if you go to our website, I don't know, Tom does our website stuff pretty much. Do we have some live videos on some of the lathe work that Joe does?
There should be some on there. I believe the opening of the homepage of the website has live tooling happening.
You guys are all seniors, so I'm going to invite you guys to come with Mr. Cuban here sometime through before you graduate, obviously, because you'll probably be gone after graduation day, right? He can bring you guys over, and you'll see firsthand some of the things that we do in our shop. We're a tool and die machine shop. Milling machines, lathes, welders, surface grinders, saws, that type of thing. You've got the basics here that you'll learn what to do in certain applications. We do it all day, every day, and these guys are masters at this. I asked Bill about if you had a STEM program here. I'll just tangent off for a minute here. The work that we do, these guys are programming CNC machines. They're making one-of-a-kind complex parts. These guys are really craftsmen. They can make anything that comes our way that fits in our machine. Some things that don't fit in our machines too. I can give you a couple of examples. They look at me like I'm nuts sometimes when these jobs come in the door, but if a customer needs something and there's a way we can do it, we're gonna help them out. That's what we do. We're a job shop. We don't have a product where we're printing out or stamping out or making a zillion of the same thing. We do onesie, twosies. Once in a while we'll do 100 pieces of something, but that's the exception to the rule. But in our shop, these guys are running some big machines, some complex machines, complicated machines, and for you guys that are getting into the working world, if you get into machining, you're going to learn why things are accurate, why the machines are made the way they are, so you can make parts that are cut square and true. And that is, if you want to use it as a stepping stone to get into other work like engineering, that's a natural transition to go up the ladder with that. Now, some of you guys may get into the working world right away. Some of you might go to school. As you make those steps along the way, you're going to learn different things. You're going to get these experiences, but you'll be able to apply it to what you learn. You know, by the time you're 50 years out of high school, you've experienced a lot of things, so you learn a few things. So it's interesting to do that. But these guys over our shop really can do an excellent job. I couldn't say enough about how good of a job they do. I got a few things I brought along here for the classroom here. Here's another old-fashioned book here. This is this year's version. They still put out paper copies. This book is for all the supplies that you would need in a shop, and there's a million varieties of everything in this book. So, if you need a 3/8 16 tap, you know what tap is? No. That's where you cut threads into a block. You drill a hole first, and then you cut these threads into the block. That tool is a tap. You got any here?
Oh yeah.
Let me grab one here. So, if you go and look in the catalog here for taps, there's probably about 1/4 of an inch of pages on taps. There's so many varieties because, again, everybody's got different products that they make and requires different kinds of tooling to make the product right. These are all taps here. It's got different size threads on them. There's probably 25 different taps in here. There's also dies. They'll cut the thread. If I can get one out of here. they'll go over a piece of steel and cut the threads on there so it can screw into the hole that you threaded with the tap. I don't want to get too technical on all this stuff here, but this catalog here, you probably got this thing out of this catalog, Bill. Do you buy MSC?
Yeah,
Okay.
yeah.
Question?
I actually have a question about your welding program. So the guy actually, when you came to a few weeks ago, me and Christian were welding. So how often do you, like you said you guys weld almost every day?
Yeah, we
Somewhere
don't do a
around
lot of welding in our shop,
Yeah,
but
but every now
we've
and
done welding.
Oh, so what other, so like besides MIG and obviously stick welding, you guys also do TIG sometimes?
Mhm. We got all capabilities to do that, yes.
Okay.
Just it's kind of funny you asked that question. We've made a lot of stuff for a lot of places over the years, and one night I was delivering a job about 10 o'clock one night at a customer that we had welded up, big contraption that we welded, and this is getting a little off subject here, but I pulled in with my truck, and the guy got the overhead crane out, lifted this object off the truck, and the foreman is there, and I had been dealing with the guy. One of the guys unloading it was one of the welders, and he says, "Hey, Huck, I thought we weren't supposed to use hard wire on welding this stuff." So my ears perk up, I'm thinking, what's he talking about? Well, the wire that we used to weld these parts together was made a certain kind of a look on the weld, and that wasn't what the guy was supposed to be doing. He was supposed to use a softer wire so the weld wouldn't crack. It was more flexible, or I didn't even know what all the deals were on that, but there's so many little variations, and I just happened to catch what that guy's comment. I didn't say nothing, I kept my mouth shut, but the guy that I was talking to, he says, "I'm gonna give you a spool of this wire, and you can put it on your MIG welder, and I'll let you use that." So after that, we've been using that ever since, because it's not the brittle wire or the brittle weld that gets put on there. But that gets back to our multitude of products that is in this catalog here. So if you look up, if you want a 3/8/16 tap, you look in the book under 3/8/16 taps, and there's 16 pages of 3/8/16 taps. They're all different. You would never see that online, necessarily. You go in there and say, 3/8/16 tap, here's one right here, so you order it. Well, it might not be the right tap for the job. There's oversized taps that, tap a little bit bigger, because if the block gets heat treated, it shrinks. There's a wealth of information just looking alongside what your object is that you're buying, that you can say, okay, this might be better than what they're showing me here, so let's look at it. So I'm leaving this here for you also. Where's that marker? I'm gonna put CMHS on this one too.
I'm sure we don't have that.
That would be in a shop like this.
I was hoping that they would send me one of those.
They send them out once a year. I asked the guy to send me one. This is my copy,
Okay.
and he's supposed to be sending me one. So when that shows up, I'll still put it on my shelf, and you can keep this one. This is a 2014 to 2015. I guess it's not brand new.
It's okay.
But I go online all the time and look for stuff. Or the guys in the shop, they know exactly where to find that stuff. I'm all thumbs when it comes to computers, but I can find stuff in here if I need to, and there's just you can't believe how many options there are. There's about as many options for products in here as there are jobs out there. You just got to find the right job for you, okay? Okay, I brought some other stuff along here. I told, you guys can hand these things out here. These are decimal equivalent charts. Same, it's kind of like that stare chart that's on the wall over there. I was hoping to get some small pocket-sized ones, but they haven't come in yet. So take one and pass it around. That tells you all your decimal equivalents. There's a little bit of math in here. Who likes math? You like math? Oh, then you change your mind. I can understand why.
I'm good at math.
Let me tell you, when math comes along, it's hard to understand. But when you're making something on the machines, then you can understand how you apply that math to what you're doing. You've got dimensions, that's math, numbers that you got to work to. Everything that you make is going to have numbers that you have to add and subtract and figure and everything. So that's going to help you out with that. I might have mentioned to one of you guys last time when I was in here, we work on parts that we do. They get some pretty tight tolerances. I mean, you've got to be plus or minus what kind of dimension. And I think Bill, at that meeting that I was at that one night, you said you guys can work within a 64th of an inch. So look up on the chart 1/64th and tell me what number you see next to that.
.0156.
0.0156. Okay, so 1.000 is 1,000 thousandths of an inch. That's when you got 3 zeros after that one, it breaks an inch into 1,000 pieces. Okay, so you've got 15 thousandths is what that 1/64th is. So there's 15 thousandths of an inch in a 64th. Now our tolerances that we work to, we work to plus or minus 1,000th of an inch, 1,000th of an inch. I told one of you guys last week when I was here that a piece of hair is about 2.5 or 3 thousandths in diameter. So we're working to tolerances less than a piece of hair. All your machines over here are made to those kind of tolerances, so they are accurate and everything fits together and slides good. I mean, they've got to be accurate fits. Did I say anything about this kind of job leads into engineering or other things? I thought I did. You weren't listening, see? I'm just pulling your leg. Basic machining, if you learn to be a machinist or tool maker or a mold maker, you're going to learn a lot of things that would help you converse with an engineer. Because a lot of the engineers that come out that we have to deal with their prints, I wish they would have called us first, because it's, you know, I'll draw it, you make it. Well, thanks. I had a drawing come to me yesterday to quote, and it was a piece of aluminum. Six inches long. One was 4.5 inches in diameter. So we got, or 4 1/4, whatever, 4.5, let's say. Okay, what's the decimal equivalent of 4.5?
4.5.
Right, 4.5. We usually work in 3 decimal places, but 4.5, that's correct. Anyhow, this thing here, this is the outside diameter, the shape of it. 4.5 diameter. This might have been 3 3/4. What's the decimal equivalent of 3/4?
750.
Okay. 1/4 is 25 cents, 0.25, right? Half a dollar is 50 cents, 0.5. So 3/4 is 3/4, 75 cents, 3.750. Anyhow, this part had on it a hole in there. And the hole was, I think it was a 3-inch diameter hole, 3.000. And it had a square bottom on there, okay? Joe's shaking his head. Okay, so he drew it. I got a hole that's got a square bottom in there, a flat bottom. And so I'm thinking, what goes in here? Because there's a pipe fitting here and a pipe fitting here. So that tells me that there's water going in there or liquid or something. Or maybe that's a vent or a pressure valve gets screwed in there, something like that. So I sent the guy an email. I said, you know, do you really need a flat bottom on the pocket that we're making on these parts? I haven't got a response from him yet, but if we could at least put a little drill point in there when we go in and make the hole, then we can get in there with a bar or a tool that will cut a square corner out. But to try in a lathe to make a completely perfectly flat surface in a pocket that deep is very difficult. You got to get a tool in there and move back and forth. There's no place for the chips to go. It's a question that we're going to ask right off the bat. I don't want to make that flat bottom. Can we put a drill point in there? What goes in there? Is there water going in there? We don't know what the part is. Ask a question. Ask an engineer. He's the guy that drew it up. Every line on the drawing is there for a reason. If you're not sure, or if you're curious or critical about things, here he's got a 3-inch dimension on there. So what's the tolerance on that? We tell everybody in our shop we go to plus or minus 3 is the worst case scenario. So if we make this 2 inches 9/97 and a 3-inch part goes in there, it's not going to work. Because typically a drawing down in the corner is going to have a tolerance block that says 3 place decimals or plus or minus 5,000 sometime. That's a lot. So we make accurate parts, but we need to know, is there a 3-inch piece going in there, or is there water going in there, or does it fit the air? So if you have some basic understanding of some of the work that we do, and a question comes up, you can ask the engineer. You guys call them all the time to get that sorted out there.